Let's take a piece of paper and start to draw this flowchart together. In this system, we have two types of electronic units, A and B. There is a part prep station for each type of part. Both will go to a sealer station for assembly and testing. If a part passes the test, it will be shipped, otherwise it needs to go to the rework station. If it can be reworked, then it is salvaged and shipped, otherwise it is scrapped. Apparently, in this case, the entities are the parts, the resources are the workstations. Here are the input numbers for the part A. Let's not worry about how they were determined at this moment. Just take them in your paper. Parts of type B come as batches of 4. Imagine that they come together in a box. After arrival, we process them one by one, so this is a bit different from part A. Based on the actual real-world operation, we decide to run the simulation clock for 32 hours. We are interested in a few statistics, including resource utilization, queue length, and cycle time. At this moment, we should look at this model and think about a good way to implement this logic. Think through the process. What entities, what resources, what parameters? Let's get started by creating a new blank model. We drag and drop modules into the flowchart view. We fill in the parameters for part A create module. We fill in the parameters for part B create module. After each create module, we use an assign module. This is where we assign some important attributes. In this case, we add 2 attributes for part A, sealer time and arrive time. Remember, these 2 attributes are tied to part A. They will be used later in the process module. We use an assign module for part B2. We also define 2 attributes, sealer time and arrive time. The names are same as those for part A, however, the values are different. Remember, in the hand-drawn flowchart, part A goes to prep A station first. We use a process module to represent this station. The actions are cease, delay, and release. We need to define the resource. In this case, the resource is prep A station. The surface time is defined as a triangular distribution. Similarly, we need to specify the process module for prep B station. We also need to define the resource and delay time. After preparation stations, parts need to go to the sealer process. We need to define a resource sealer. For delay, we refer to an expression we defined earlier in the assign module. It is called the sealer time. This is an attribute. Both part A and part B have it, but with different values. After sealer station, we need to check whether the quality is good or not. For that purpose, we may use a decide module. Decision can be made either by condition or by chance. In this way, we go with by chance with 2 possible outputs. 9% it is going to fail. Otherwise, it is going to pass. If it does fail, we send the part to rework station. So here is the rework BasicProcess module. For delay, we used an expression. After rework, we need to decide whether the rework was successful or not. Again, we use a decide module, and we use by chance too. We are interested in collecting a few statistics. Although Arena is able to collect many statistics automatically, very often we need to clearly specify exactly what we need. For that purpose, we can use record modules to collect tallies. In this case, we want the cycle time of the parts sorted by their exit point, that is, shipped, salvaged, or scrapped. There are two record modules. We show one of them here as an example. We use time interval as a record type. We refer to an attribute arrive time, which was defined earlier in the assign module. So in this case, the tally will subtract the arrive time from the current time, which results in the total time that the part spent in the system. In the end, we need to dispose all the parts. We use dispose module for this purpose. Before running the model, we should go to run setup to specify the run length or how we want the simulation to terminate. As planned earlier, we would like to run 32 hours of simulation clock. We consider 24 hours per day. Please note the time units. When we define the create modules, we actually created two types of entities, part A and part B. If we click the entity button in the project bar, we can see and edit them in the spreadsheet view. We would like to change their initial picture because they will show up in the queue animation, and we would like them to look different. At this moment, we can check the model and try to run it. If it has no problem, we will see it runs with animation. Otherwise, we need to check the model and fix any errors. In the end of simulation, we are asked to view the results. Arena provides a lot of statistical results. We need to look into the report and single out the results we are looking for. This is just the result of one replication. We must run multiple replications to get better statistical results. Are you able to find the cycle times sorted by the exit points?